I am local, like I said, from Jersey. I do meetups in New York and New Jersey and Philly, covering AI, data, Python, Java, lots of fun stuff. These are the slides for today. If you want to get them, make it easy. Just in case we have to skip some or someone announces something cool outside, almost end of the day here, lightning talk's coming. We have some cat stickers in the front. You can grab it anytime. This is what it looks like. I was gonna bring it, but Microsoft Office and Internet is sometimes tricky, so it's sitting at my desk at home, but we'll try to remotely access it. And I have some captured videos just to see. Sometimes the cats jump on the camera at home. If they do, we'll try to get that. Now, I have a couple articles that go deeper into this, because in 30 minutes, we're not going to cover all the nitty-gritty. And this goes as deep as possible. This covers how to get the right hardware, how to assemble it, test it, get all the libraries working, put a little rubber cat behind it, all those important things you need when you're going to do Python, plus Raspberry Pi, plus custom AI hardware, plus vector database, plus some AI libraries all at the edge. And this works pretty well. Now, of course, I wrote this a couple months ago. As of 2 weeks ago, they released a better version that has double the performance, and I have it shipping, didn't arrive yet. It is actually double the speed, so I'm curious how that'll be. I'll post results for that one. And this is the second article. This goes into using some different models they have, and how you can use those. Goes pretty deep, includes videos and the source code and all that. This is the first set of source code. Again, if you get the slides, it has these links. You make it easy, make sure no one misses out on anything. And the second source code. Now, who's really looking at this to see if I can keep it the same? It is. If you found one, you find the next one. And then a walkthrough article, I think we already linked that one. So we're going to go over a little background on the stuff we're working with, a little overview of the hardware, the AI, and the models we're using, try to go through all the demo pieces, how they connect together, and then go over the problems we had, which are not surprising, because there's a lot of stuff. Now, what's important about this, and why I thought this was interesting, is unstructured data is huge. And I think it's going to get bigger and bigger as more AI is involved in stuff, because everyone has documents and logs and images, videos, tons of different things that go along with all the data in the world. What's nice is with something like a vector database, we can take that, apply a deep learning model, convert it into a vector, just a set of large dimension arrays, and store it. Once we have it stored, I can do really fast queries against it. Fast enough that I can upload an image, and by the time it's finished uploading, get back the nearest images that match it. And with some of the new models out there, I can take a text that says, give me cats that look like this, and search the models with no metadata. It is mapping that and doing a similarity search, because it's mapping text and images to the same space. And those models are really cool. There's also some where I can mix and match, where I can do text and image, and I'll show you some of those too. So we're in a very interesting new world of what we can do with these models. Some of that we can use directly against a large language model to ask questions. Other to use that for searches, then combine it, and then combine it with a model call again. And I'm doing one where we're doing that, and when we get the results, we make a new image of all our top matches, and then we send it to a model. I'm running this all on the laptop with a llama. If you haven't used a llama, it is awesome. You can call it right from the command line or call it right from your Jupyter notebook. And I'm running Lava 7B on there. This is a multimodal model that supports images, and it is pretty decent. Now, it's not GPT 4.0, but it's free, and the results are pretty good. I'll show you what the results I'm getting. Milvus is the open source vector database that I'm using. You could also use Chroma. There's a bunch of other ones. This is where I work, so I use this one. But this one is kind of nice. All of the features here, open source, runs in the notebook locally as a local database file, or in Docker, or in a Kubernetes cluster, or in a commercial cloud, and you get all the support for any of them, which is nice. And it supports a lot of features, which is important, because sometimes you want to search by text, sometimes you have sparse text. So we support every type of index, every type of searching, all of that, with the ability to scale out as big as you need to, or run it small just to store some cache. And the code is the same. You're just going to point your client somewhere else. You know, whether it points to something local or something in the cloud. So the Raspberry Pi 5, the new one, supports up to 8 gig of RAM, which is a decent amount. Then when for $70, you add on this hat, which is a very fast bus that they've added. This is the new style of hat, the M2 hat. And this attaches, costs $70, adds 13 teraops. That is pretty fast. To put it in perspective, the older NVIDIA devices from maybe 3 years ago were at that level. So now $70, I added onto a Pi. I got an 8 gig, mini server that I can bring anywhere, run multiple cameras, and do some pretty cool stuff. Just updated now. There is the A+ version of this that makes it 26 hours. That's pretty nice. That is coming, like I said, they're shipping in like 2 weeks. So pose estimation, if you didn't know, a lot of papers about it. It is an interesting technique for finding points on people, and it's just for looking at people. This happens to be one of the ones that come on the AI kit, so I thought it was fun to play with. It'd be cooler if we could point it into people crossing the street, and I thought of setting something up in Times Square to see all the Elmos crossing the street and see if we could get their joints in motion. I might do that around the holidays. I think that might be the most interesting time. But it's a kind of a cool one. So what I'm doing is taking the code that grabs all those points, tracking them, and then I'm grabbing the points I like. And I'm doing a sampling because I have a small database sitting on the laptop, so I didn't want to, put in a lot. If I can connect to the server, which I hope I can, I'll show you how quickly it's going through points, even with dumping a lot of information out. So even on the small system, it's pretty fast. Now, what's nice is it is using standard models, pretty easy to find. These are pretty good, and they run pretty fast, so I can't complain about it. There is, if you get one of these devices, again, pretty cheap, they just added more examples, which I want to play around with when I get the 26 op one. The Club Zero shot looks really good. Again, having that more horsepower at the edge is going to make that a little easier, so that should be fun. And again, what I'm injecting is when we find the eyes, I'm formatting that, and then I'm sending that to the vector database. So I'm sending in here I'm taking the embedding from the image, because it captures the image when it does that pose. I grab that image, vectorize it, and add some metadata. Now, we don't need metadata, but why not have it? why not have as much data as you can get? So I can say, hey, just give me, and I'll show you this in the query, give me things where you're 90% confident it's a person. And give me the image, and give me the points where the eyes are. Again, maybe you want to track something through a space, you know, whatever your use case might be. Again, we could do, we're grabbing the vision, analytics on the images and videos. We're getting the images from the camera. We could also get audio. We could get video. Video's a little harder. We could get raw text. Now I'm generating raw text with some models as well from these images to add to the metadata. And we could have people, you know, grab data. I can grab it from Slack, Discord, other places. And we can run additional models at the edge on this device, depending on what you want to do. I could also run a llama on a Raspberry Pi, and I've been able to do that for some of the, you know, lower, smaller models, some of the ones like 1 billion, 3 billion. Once you start getting bigger than that, it gets a little tough. Let's see if this actually works. This was a capture that worked. Okay,
Just want to make sure we get.
Yeah, we don't need to go. Now, I will try to connect to it as well. It produces a lot of, as you can see, it's moving pretty quick, the amount of frames we're going through. That is a video of me trying to set it off to see if I'm a person, and sometimes it agrees. So it's fun to get, and this is where my left eye is in the space. Kind of scary application for the Palantir people, but for the rest of us, you know, you could draw funny faces on people. What you want to do. So that's the idea. You get, you know, you connect to it as it's going through. And we can go to the next one. And what we're doing is, as we're collecting the data, I send it to Slack, individual pictures along with some of the metadata. Now I'm going to try to do this real world, but I'm not sitting at my desk in front of this. So unless a cat wanders into the page, you may not see it. Let me see what else we got. Maybe we could try the demo here before we go into next step. I'm going to try and connect. And maybe we could do it for real, maybe not. If you haven't seen this, the new version of Raspberry Pi has a remote network for you to securely log in via SSH and also a remote window, which is pretty cool. Did it actually work? And will it be fast enough to run? Well, let's see. Oh, maybe. Now, I'm probably not there in front of the camera. If I am, something really weird's going on, and that'll be scary. Now, it's probably not going to detect anything unless the cat's there. I put some treats on the chair, but I was trying to put a human analog there. I thought I made something that looked close enough to a person that might detect it, but it didn't. I think it needs to have some kind of movement. So maybe I need a doll that kind of moves, a little robot. So if there's no one sitting there, doesn't capture anything. Oh well. But we could show what's going on here. Okay, go back here. Now, when I'm capturing this, like I said, it's sending it to my Slack channel. And it's also storing it in the vector database. This is a viewer into the Milvus vector database I'm storing it into, which is sitting on a machine next to the Raspberry Pi, just a little desktop. And I've been able to upload a couple rows. You can see here all the metadata, as well as I have one vector, just a little one for the image. And you know, the different points you capture. And then we can do a little search there, take a look at the data it has. And it's got a couple different fields here. We also have the ability to visualize what's in there and what's the results. Just to show where the data is, and you can see we have that connected picture. Now the way I have the connected picture, we are storing it as a vector, so we don't instantly grab it as a vector and convert it to an image, because that is slow. So remember I said metadata? Well, I put the URL for the image there. So I upload this to a free image hosting. Sometimes I do it to Minio or S3 into the file system, but free image seems to work pretty well. So I have some of them there. So we have that data stored. We can query it. So what we can do is, I'll show you a little notebook here with probably too many libraries. Maybe I'm using them all. There always seems to be like, you need one more library, then you add another one. This is how I'm going to embed the model using ResNet 3.4. Set up a couple things to connect to the data source. And here we'll run this and we'll get the current query. So what we're doing is grabbing the 10 images where the label, remember that filter per person? So it's a person and the confidence is pretty high. Giving back the label, confidence, and the URL of the image. And I will show you that. Plus I'll also download the image and display it on the screen here, as well as post that message to Slack and post the image to Slack. Or did I just do? No, I did 2 messages. I should have uploaded the image too. What do you think? So we got the detection and all that information. So I can have as many of those devices wherever I want, upload that to a central vector database, and then make it available for analytics. Now you could use it for tracking people at a conference. Like if they opt in to say, hey, if you want to know where I am, you know, I have a couple of them around, and then go to a kiosk and go, where's Tim? To give me where I was last. Where is Tim if he's holding a picture of a cat? You know, I don't know what kind of weird use case you'd have there. You could do that. On the edge, the code doesn't look that much different other than it has some specialty libraries from the people who make the hardware. And all this source code, it was linked in GitHub, so you can get to it. And it's pretty straightforward. The only thing I do different is set up a schema for my vector database so we can store the information. And we set up all the fields we're going to need. And that same model is going to be used to vectorize the information. So what we do is go through everything when we detect a person. Now I don't have one detecting cats. I should make sure we have that one. So we found somebody, we mapped out the points where things are, and I'm going to grab one of the frames from the video, because it is a scrolling video. I save it, write it with OpenCV locally, grab a description of where the eyes are, and then I'm going to post that to Slack as multiple messages, and then get all the fields I want here, and upload that image to Slack, and then insert it into the vector database with all those fields and where stuff is. And there's some other things like what individual points we get from the pose estimation, you know, nose, face, all those things you expect people to have usually. And we post them up here, and it comes in something like this, where it's detected. See, I tried to put a little, I had a giant rabbit and I put a mask on it. I'm like, that'll look like a person. The one time AI is too smart. I need to find something better there. But it found when I was standing there testing it, going, oh, see, it'll work, yeah, because it got my arm. So I gotta have a better remote work. They almost, but it got my movement there. So pretty good way to do that. Now, if you wanted to do something more advanced, again, if you're doing something advanced, you want cats. Which again, I gotta try to get them in a place. I guess I gotta put a lot of cat treats out, put it in front of the camera. Trying to time that right at a conference, not as easy. So in this notebook, I'm doing a multimodal vector search. All this is running locally with Llama. Now, I originally tried the new Llama 3.2 vision model, but I found out it's not as good as Lava, which is a custom-made, also open model that works, is actually trained on 3.2, so I don't know why one's so much better than the other. This is running locally, so I just have a little Milvus database there. I connect to it, and the model with PyTorch here. This one is really good because it lets me do text and image at the same time. I vectorize them together and store that, so I can have things together. So here, first up, I get all the images I'm going to work with. I load this up from some images on my desktop, and then I'm going to create that collection. And here I want to do a query where it's show two cats together. So I'm just going to encode that text to do my query. Now I'll show you what's in there. What's in there is the encoding of image plus text. And this will search the image and text together, mostly searching the image. And if we run this one again, I don't know why it's frozen. Okay, there's the results. That's two cats fighting over this little house I got them that looks like a pumpkin, and they're tearing it apart. We got a couple results that match. So I'm going to take one of the images of cats, plus a text saying, similar to this cat but white. Now the cat here is black. So I'm going to encode those together. So those get vectorized. Then we're going to do a search, and that's the only thing I pass in, is that image and text together. And then I'm going to show you the results there. This is the input. So what did I query with? A cat picture and this text. And the results it gave back to me, pretty much a white cat. So that works pretty well. I mean, depending on how tough your query is. Now the second thing I do is take a bunch of cats, combine them together in an image and number them. And why this is interesting is, in the next step, I'm going to call Lava 7b with that big image and a prompt telling it what to do with it. Basically, the instruction says, try to find the best result here, rank it as a list, and then pick the best one. And this is when I run this locally, it takes about a minute because, it's not super fast, but it goes through that, gives me back a ranked list of which image in that top image it thinks is the best. So that is this image, and it goes through this and makes a list of which one it thinks is the best. That's the re-ranking algorithm. And then it gives me a reason, like feline, okay. And then it gives me the picture. I think that's a pretty cool way to be able to do that without really anything too difficult, and all open source, all Python, all running locally. Now, does anyone have any question on what we've done so far, or on something you might want to see further? Otherwise, I'll just run through more cat pictures.
So is everything running on the Raspberry Pi?
Now, this right here is not running on the Raspberry Pi. This is a notebook running on my laptop. Now, you can run this notebook on a laptop, and you can run a Llama. Now, if I turned off the live demo that's doing the capture, it would run okay. It's a little heavyweight to run both. You could do that on a Jetson, especially the new Orin level ones. I don't know. I run this notebook there. It's slower. Llama's slower.
So
I wouldn't run both. I think the Python, the Raspberry Pi is better for running just a capture, which is doing enough because it's running the live video, adding the pose estimation on top of it, capturing everything that we detect every time we detect a person, then getting all those values, vectorizing it, putting some things into Slack, and making a call to Milvus. Could also send a message to Kafka, use bytelash, and then doing all that in real time, pretty fast as you saw the frames go live. Would I try to run other stuff on there? No. If you wanted to stop and then run your analytics there to test, you could. Like I said, Alamo will work there. Milvus Lights will work there. Is it the best use for the pile? No, but if that's all you had, or if you're in the field and you wanted to test, I recommend running either on your laptop, the notebook, or on a little server somewhere, depending on, because it is distributed, it's a handheld device. Should you run it there? Now I know they're going to be increasing the hardware for that soon. So when they make the next iteration of the pod, that's probably going to be 16 gig of RAM, probably double the CPU. You add that with these new AI hats, maybe then you do run it there. But again, I think I'd rather focus the Raspberry Pi on capturing things at the edge. Being connected to a smart camera, gathering data, sensors. Because I also have one where I'm doing that camera, plus I also have sensors, temperature, light. Do you want to run all that in your analytics on the same tiny box? Probably not. Maybe if you're a student and you want to save some money. But I recommend run the notebook on the laptop. Yes.
No, speaking of the Raspberry Pi, when you SSH into it, right, and that's, I assume it's in your local network.
Yes.
So you had to expose like a port 22.
Well, there is, thanks to Raspberry Pi Connect, they have a special VPN that is part of the, if you look, this is their official one up here. You open up, you connect, you install it on your Raspberry Pi 5, and it securely connects, and there's all kinds of things you have to do to set it up. And then you can remotely, not just SSH, I can remotely screen share. So that's how I can run this, and I can run local cameras and see all the apps on there. It's not super fast because it's going through VPN and mine's sitting at home, but yeah, you don't have to hand code this anymore. And it's
that's
reasonably reliable. I have it isolated at home in its own little network with one port through the firewall, just pointing to this.
Yeah.
Even with the VPN, it's not connected to anything else on the network. But
good. So
and then when I'm done with this talk, I close it down. But no one has tried to hack it. I guess they're not looking for it.
Yeah.
And so far, so good on this.
Okay. Good.
Again, there's nothing on that box. It's not open source. I could just re-image it if someone tried to hack it.
Yeah.
But yeah, I recommend taking a look at this. It is free and comes with the Raspberry Pi now. So a nice way to connect to your machine remotely, either screen sharing or remote shell. And it's pretty quick. Any other questions?
Yeah, for the video streaming part, did you see any frames being dropped or lost or anything like that?
They don't really tell you that. I'm sure there's some metadata, because what they do is the AI kit is directly interfaced with the camera over a high bandwidth thing and a specialized library that's grabbing directly off the camera. And it, you can see that in some of the logs, but they don't, they don't offer it too much because they turn as much off to make it as fast as possible. Mm-hmm. Now, is it 60 frames a second, super fast like on an NVIDIA? No, but it's probably 10 frames a second. It's not too bad. Would I use this for driving a car? No. Would I use it for, casual stuff? Yeah. This is not a commercial level device. This is a home device. But For the price of a $90 computer with a $70 AI enhancement on it, with, I'm just using a web camera, it's hard to beat that price on it. And it works pretty well. And again, with the connectivity from Raspberry Pi built in, it makes it pretty easy to use. Now, yeah, obviously, 8 gig of RAM, the OS is using it, Python, a lot of other stuff. You know, the CPU is kind of weak. It's not even where we are on an older Mac. The library and the device itself is always moving. So there's a lot there. If you saw all those imports, there's not too many I can get rid of. There's a lot of libraries there. Now there are other alternatives. Like I said, this one just came out. Jensen has some awesome stuff. I also have an OP, which is a smart camera that has some of that built into the camera. And there's some other specialized devices. You know, you look down at the bottom is the one we're using here. Then you look at even the older Xavier, and it is faster, but now Raspberry Pi can be better. And then you look at the latest Jetson, that's not the super commercial one, and we're at 275 tops, so 10x even this new one. So that's the one where you're getting 30 frames a second, multiple cameras, can do a lot of crazy stuff real time. I'm working on that one. I do have one of these. It is a lot of work to get all the models working, but this will run full LLMs on there with the because of the GPU power there. So that one's pretty cool. But price difference, this is also, I think, 10x the price. So 10x the performance, 10x the price. It's not a bad trade-off. Takeaways: the closer you are to your data, you know, faster you can work on it. AI robots are going to need a lot of this, and the more they can do locally, it's safer in case networks go out, there's blips. You can do vector search everywhere, which is pretty cool. Keep your data and computation as close as you can to where you're going to use it. We already did the Q&A, but ton of resources in there. If you want to see any more of the code or additional code, I think we got a couple minutes left. Otherwise, questions, or I'll let you get ready to see if there's any that treats left before that lightning talks. Yes.
So the processing that you are doing on the Raspberry Pi,
Yeah.
like, so you're using Ethernet. So is there enough bandwidth if you wanted to put it on a drone and do it over Wi-Fi?
Yeah, there are some work on some smart drones just coming out that could do some of this. I don't know. I guess closed estimation would work. Right now, there is a Raspberry Pi drone coming out from Kickstarter. You know, you could do this. Again, because you don't need to do, once you're on your initial network, you don't need to get any more network. It just has to connect to its camera. You probably want whatever your controller for that drone that you're talking back to be able to talk to. That's probably Bluetooth, or maybe another IoT protocol. But yeah, there are drones that'll do that. And that might be next year's talk. By then, they should be stable enough. I don't know if I do pose estimation or just something simpler, just to track what's going on and be able to do searches. I do have a talk on using New York street cameras live and being able to search them. Because they're available via REST endpoint. So I ingest them every 30 seconds, pull them into Milvus, and then you can search for things. Like, you know, are there any cars on 23rd Street? Or, you know, what's the most busy part of town? And give the top 10.
Those public endpoints?
Yes. You do have to sign up and say that you won't do that stuff. That's the New York City data. New York City has a lot of open data. And they also have the data for where accidents are and where taxis are. They can tell you there's a lot of correlation. And then you can watch on the camera And you could probably write some nice ML to estimate where their taxi's gonna hit somebody next. And then go look at the camera and go, yeah. And then give that information to a lawyer. That's a good startup right there. Give lawyers, hey, just got an accident. Or just find weird stuff going on in New York as cars go by.
They just made jaywalk.
Oh, yeah.
Oh, now that it's legal, oh, there's gonna be a lot of stuff going on. That's the best of a lot of things there. Are there any more questions? I'm trying to get to that,
Have the FBI reached out to you?
non-disclosure. 2 minutes. My previous job, one of our clients was the NSA and the city of New York. Well, okay, the police of New York. They have a lot of data they don't even know is open, which is scary. Like, there's levels of camera that they only close because we told them to close them. They literally had cameras you could control remotely that would give you a 30 feed per second feed of New York. But fortunately that's closed, yeah. This is common stuff. I've been trying to do the Batman thing. You saw the Batman movie where he's tracking from phone to phone. You can kind of do that with open data now, in real time. It's pretty close. I don't know who'd be interested in that though. You know, I do things that I'm like, is this cool? And I'm like, who's this cool to? Just to me, you know. So this is the ones where the, just go to my Medium. There's articles on weird stuff. And I think we're out of time. Thanks for coming. If you want stickers, there's a couple of